Welcome back. Functions can be combined in a variety of ways to produce new functions. In this video, we consider the composition and product of functions. Let us start with the product. Given functions f of x and g of x, we can form the product f times g of x. It is defined by the formula f times g of x equals f of x times g of x. The domain of f times g is the intersection of their domains because both f of x and g of x have to be defined. For example, let f of x be the function square root of x. The domain of f is the half-closed interval 0 till infinity. For g of x, we take x plus 2. The domain of g is the set of all real numbers. The product is given by f of x times g of x, and this is equal to the square root of x times x plus 2. Its domain is the half-closed interval 0 to infinity. Let us now consider the composition of two functions. Consider a diver in the sea. To avoid decompression sickness, the rate at which the diver can return to the surface must be restricted. During the diver's ascent, the pressure is a function of the depth x, which itself is a function of time. Thus, the pressure is given by p of x of t. The pressure as a function of the time t is an example of the composition of the function p of x and x of t. More formally, if f of x and g of x are two functions, the composite function f circle g is defined by the formula on the screen. It's also read f of g and sometimes also f composed g. And what this notation really means is that we are plugging g of x inside the function f of x. Be aware that the special circle is not a multiplication symbol, although they look rather similar. The function f circle g is also called the composition of f and g. The domain of f of g consists of those numbers x in the domain of g for which g of x is in the domain of f. In other words, the composition is defined whenever both g of x and f of g of x are defined. Let's see an example to see how this works. For f of x, we take the function x squared minus x. Suppose that g of x is given by sine of x. We want to find a formula for f of g. What this means is that we want f of g of x. Well, we can plug g of x in the function f, and g of x is equal to sine of x. Since f of x is given by x squared minus x, everywhere where there is an x, we replace it with sine of x. When taking compositions, we have to be careful about the order of the functions. For example, g of f equals g of f of x. And if we plug in f of x in g, we obtain sine of x squared minus x. We see that g circle f and f circle g are not the same function. We now look at the domain of a composition using an example. For f of x, we take the function square root of x. The domain of f is the half-closed interval 0 to infinity. For g of x, we take x plus 2. The domain of g is the set of all real numbers. To find the formula for f of g, we calculate f of g of x. Plugging in the formula of g of x in f of x, we see that g of f of x is given by the square root of x plus 2. Since the square root is only defined for positive arguments, it follows that f of g has as domain the half-closed interval minus 2 till infinity.